That's right.
Good morning, everybody. Pritam, unmute yourself and tell me audible and you can see the screen. Anyone?
Yes,
Relil?
sir.
Okay.
Yes, sir.
Last class, we discussed about the measurement of force. But actually, the force is the gravitational attraction between the masses. So that we can call it as force. Usually, the force are measured by using calibrated measuring devices. For example, weighing machine, electronic weighing machine, and analytical balance, which you already used in chemistry laboratory and physics laboratory, and you might have seen in the grocery shop, jewelry shop. So those things are all force measuring instruments. So the electronic weighing measuring machine and analytical balance both are very good examples for force measurement. The force measurement is classified into two types. One is direct comparison, other one is indirect comparison. The direct comparison is unknown magnitude is compared with a known standard magnitude. For that, a good example is, so if you want to buy 1 kg of sugar in the provision shop, or if you want to buy 1 kg of onion in the vegetable shop. So what they will do, so there will be two pans are there, left pan and right pan. They keep the standard dead weight in the left side, maybe 1 kg, and the right side, by adding or removing the sugar in the cover, they measure the weight of the unknown magnitude. Unknown magnitude is the weight of the sugar. That is the direct comparison. In definition, you can define direct comparison is nothing but the comparison of known standard magnitude with the unknown magnitude. So that is the direct comparison. So for this, a good example is analytical balance, which you already used in chemistry laboratory. Next, come to the point, indirect comparison. So indirect comparison is nothing but there will be two or more translations are present. So that translation can be used as the result of the measurement. So that translation, first, so consider the example electronic weighing machine. So there will be a platform on that you keep unknown magnitude, for example, 1 kg of sugar on that. So what will happen? The 1 kg force exerts the pressure on the or force on the platform. Platform is connected to sensors. Sensors means which has the strain gauges. So the electrical resistance strain gauge are connected to the platform. Due to the force of the sugar, there will be change in the resistance. That resistance is measured in terms of kgs or grams. For that, a good example is electronic weighing machine. Here, when you keep the sugar on the platform, what will happen? It exerts a force on the platform. In turn, platform contains the sensors. Sensors contains the strain gauges. There will be change in the resistance that is converted into analogous signal. That analogous signal is converted into voltage signal, and then the voltage signal is converted into digital form that you measure the weight of the sugar in grams or in kgs. All of you observe here, this is the analytical balance which you use already used in the chemistry laboratory for weighing of chemicals. Here there will be two pans are present, that is W1 and W2. In the center, one more pointer is present, which is placed on the trapezoidal form, just like a triangular support. So the knife edge is placed on the beam. So all of you observe here, this line indicates the beam. See, here you have one trapezoidal form, other one is on the right side, that is W1, W2. This is the steel yard mass, and this is the unknown force. So usually you keep the chemical here, and here you keep the weights, that may be 5 grams, 10 grams, or 1 kg, like that. When the pointer or the needle coincides with the zero reading, that is the exact weight of the chemical. That is the procedure for measuring the chemicals. But one thing, before measuring anything using analytical balance, you have to adjust the analytical balance for null balance. You are all belongs to mechanical engineering. Remember the word null balance. Null balance means bring the pointer before applying anything. Before applying anything, remember, before conducting the measurement, bring the measuring instrument to read zero. Read zero. That is called null balance. That is called null balance. So after making the instrument to read null balance, then you start the measurement by keeping the chemical in the unknown force pan and keep the weights in the W1 and bring the needle to read zero. This is the procedure you have to use for working of analytical balance. So you have the explanation here. This is very, very important. That is the beam balance method or moment comparison. Moment comparison. And beam come to the symmetry, that is the measurement. That is nothing but when beam come to the symmetry, left side is equal to right side, and the needle reads zero, that is the measurement. All of you observe here, this is the explanation you have. You can read twice, thrice, or 4 times and write the explanation in your own sentence. Next, come to the point, very, very important. All of you, please write down the question. Write down the question. Explain briefly. Explain briefly with neat sketch. With neat sketch. Multiple lever system or platform scale. Platform scale. Put a question mark. Explain briefly with neat sketch multiple lever system or platform scale. Continue the question. List the applications. List the applications. list the applications. All of you mark it, very, very important. This time, 100% guarantee you have this question in the examination. That is in first portion of the fifth module. You have two questions in fifth module. The first question in the fifth module is multiple lever system or platform scale. One more important announcement for you. This third test, all of you listen properly. Third test is offline. Third test is offline. We will conduct the third test in the classroom. In the classroom. You have portions from fourth module and how much portions covered up to that date will be in the test. Remember, all of you, the third test is offline. We will conduct the test in the classroom. Question papers are same. Test is offline. Say, all of you observe here. Many of you gone to APMC in wholesale mandis. They deal with jaggery, onion, and some other items. You might have seen the APMC yard where the mandis are located. There they use the platform scale for measurement of higher weights, larger weights. For example, more than 10 kgs or more than 25 kgs or more than 50 kgs. They usually for the measurement of rice, measurement of sugar, measurement of dal. So everything is available in the bag of 25 kgs. So normal electronic weighing machine or normal scale, that is the analytical balance used in grocery shop and vegetable shop. You cannot weigh 25 kgs or 50 kgs. For that, the instrument used for higher weights or platform scale. So one thing to learn properly platform scale. This is very, very important. Almost all the question paper, you have this question in the examination. First, come to the point. There will be a beam like this. There will be a beam like this. So after that, there will be a counter moving poise. Counter moving poise weight. Poise weight. There will be a pointer is there, and here you have the graduations which is running from 0 to 50 or 0 to 100. That is which indicates the 0 to 9 kgs. If this pointer coincides with the number 4, that is nothing but 4 kgs. That is 4 kgs. Suppose that number coincides with the sixth digit, then that is 6 kgs. And next, the manufacturer of the platform scale, he provides a counterpoise weight. Remember, counterpoise weight. All of you seen in the mandi, in the APMC, the counterpoise weight means, suppose if you want to weigh 10 kgs, 20 kgs or 50 kgs or 25 kgs, for that, what you have to do, keep two dead weights, measuring weights, counterpoise weights here, 10 into 2, and move this counterpoise weight to read fifth digit. That is 10 plus 10, 20, and this pointer exactly at the fifth position, that indicates 25 kgs. When This beam, remember, beam balance. When the beam coming to the symmetry, that is the measurement. That is the measurement. And this beam is supported on a tension rod. All of you observe here, this rod is called tension rod, and both the ends of the tension rod is supported on triangular edge. Bottom and the top, both the tension rod are supported on triangular sharp edge, and the back side of this beam there will be a adjustable counterpoise. Say, you know that you have to bring the instrument to read null balance, that is 0, by adjusting counterpoise, adjustable counterpoise, that is nothing but there will be a threaded rod is present. On that there will be a nut. You can turn the nut in clockwise or anti-clockwise direction, bring the beam to symmetric condition or symmetry. That is, the beam oscillates up and down. When it comes to that standstill condition, that is the measurement. And the end of this beam is connected to a triangular sharp edge on tension rod, that is in the top and the bottom, and the bottom is connected to a platform. All of you observe here, this is the main platform which is connected to the tension rod. On this platform there will be a one more platform which is fixed at one end, other end is exerts the force on the platform, and above this there will be a main platform. Here you have to keep the rice bag or sugar bag on that. This platform of dimension 1.75 feet by 2 feet. Imagine the width. Then you keep the rice bag or sugar bag anywhere on the platform. All of you observe here, W1, W2, W1 plus W2 divided by 2 will give you the weight W. So that is the advantage of using platform scale. That is, if you keep the rice anywhere on the platform, you will get the accurate measurement. You will get accurate measurement. Once again, the beam of the platform scale is connected to a counterpoise weight. The counterpoises are available in the range of 10 kgs, 20 kgs, 50 kgs, and 100 kgs. That you have to keep it here. Then the moving counterpoise, you move on the graduation of the beam, that indicates the, that is 40 plus this moment, 50 plus this moment, that indicates the measurement. That indicates the measurement. So in the examination, you have a simple question. Explain briefly with neat sketch multiple lever system or platform scale. So for this, write this diagram and explain that. And you have a small derivation, that is, remember, force equal to tension into radial distance. That is, say, all of you observe here the dimensions A, B, C, D, E, F. That is very, very important. E, F, G, H. So you have to, you don't take G, only H. Up to A to H, you have to write the dimensions in the diagram so that you can easily derive an expression for force equal to tension into radial distance. F equal to T into R. F equal to T into R. That is tension T and the distance A plus B, like that. You have to derive a small derivation is that. All of you observe here, that is tension equal to force into distance. Tension T, from that equation, from that you can calculate the scale multiplication ratio. You have a small derivation, that is T equal to F equal to T into radial distance. That is the measurement. So in the examination point of view, you have this question for 10 marks. The examination point of view, this is a very, very important. Next, come to the point. Say, in the basic material testing laboratory, you have universal testing machine. As per the government of India and the rules made by the government of India, any measuring instrument should be calibrated once in a year or once in a 2 years. So you have to calibrate the force measuring instrument. So we have universal testing machine. When you will come to the college, I will show you the universal testing machine. In that, you can load the specimen in tension, compression, shear test. All the tests are easily conducted by using universal testing machine. The name itself indicates universal. That is nothing but you can conduct any type of test is possible. Any type of test is possible. Say, as per the guidelines, rules of the government of India, they have to calibrate the measuring instruments. Suppose we have problem in universal testing machine. Say, universal testing machine means you can load the specimen not in kgs, in a ton, in tons. You can load the specimen 1 ton, 5 ton, 10 ton, 50 ton, and also 100 ton. You can load the specimen up to 100 tons is possible. Because of higher load, there will be wear and tear. If you use the universal testing machine continuously for 5 years or 10 years, there will be some problem in the result. So that you have to rectify, that you have to avoid by using the instrument, the calibrating instrument. So you have to use the calibrating instrument. The calibrating instrument which is available, that is a proving ring. Proving ring. So this type of device, proving ring, is used for calibration of universal testing machine. All of you observe here, there will be a aluminum ring is there of diameter or rectangular cross section, circular ring is present. So this is the main component of the proving ring. On circumference, diametrically opposite to two sides, there will be a rod or there will be a projection. This end and this end you have to place in the universal testing machine, then apply the load on the proving ring. See, if you go on applying the load in interval, that is 500 kg, 1 ton, 1.5 kg, 2 ton, 2.5 kg, 3 ton, like that you can load the proving ring up to 10 ton. The reed thread, so reed is nothing but a thread. There will be a dead weight is present. Below that, there will be a micrometer. So this reed or the thread along with this weight oscillates in forward and backward direction due to the loading of the proving ring of 1 ton or 2 ton or 3 ton or even 10 ton or even 50 ton load on the proving ring. This reed oscillates in the forward and backward direction. Backward direction. If the reed come to the standstill condition, say for example, third division, then there will be a problem in the universal testing machine. By adjustment, hydraulic loading is there. By adjusting the hydraulic loading, bring the reed to zero. Bring the reed to zero. Like that, you can calibrate the proving ring. Like that, you can calibrate the proving ring. Please, all of you, write write down the question. Please, all of you, write down the question. Write down the question. Explain briefly. Explain briefly with the neat sketch proving ring. Explain briefly with neat sketch proving ring. Put a question mark. Put a question mark. List limitations. List limitations and advantages. List the limitations and advantages. Once again, the universal testing machine which we use in the metal testing lab, that you have to calibrate once in a year or 2 year once. So the procedure is very, very simple. Load the proving ring in 1 ton, 2 ton or 5 ton. While loading, the reed or the thread along with this weight oscillates. So when the reed come to the standstill condition, suppose if it come to 0 reading, then the machine is correct. Suppose the raw weight with the thread coincides with the first division or second division or third division in left side or right side, then there will be a problem in the hydraulic loading in the universal testing machine. Then adjust the hydraulic loading so that the read should read the 0. That is the calibration. So like that, you can calibrate the universal testing machine or heavy weighing machine. And also this is called compression type proving ring with vibrating reed. Reed means thread. Reed means thread. So this is also appeared many times in the examination. You can read twice or thrice the explanation you have here. Next class, I will start the new chapter, that is the torque measurement. In the examination, say in the 5th module, the first chapter in the 5th module is force measurement. Force measurement. And the second chapter is the torque measurement. Next portion in the 5th module is pressure measurement, temperature measurement, and strain measurement. So these 3 chapters in the second portion. So the proving ring is the last portion in the first chapter of 5th module. Once again, in the first chapter in the 5th module, start with the force measurement. Force is nothing but the gravitational attraction between the masses. How do you measure? By 2 methods are available. One is the direct comparison, other one is indirect comparison. That is direct means that is direct. That is directly comparing the unknown magnitude with the known magnitude. Indirect comparison, there will be 2 or more translations are present. That is the analogous signal is converted into voltage signal. Voltage signal is converted into digital form that you have to read in the digital display out. This digital display in terms of kgs or grams. Next, this is a very good example. Almost all the question paper, you have a question on analytical balance. This is very, very important. This is the simple weighing machine which is used in everywhere for measurement of unknown magnitude by using standard known dead weights. And next, come to the point, very, very important. This time you can expect this question in the examination. Multiple lever system or platform scale. You have a simple derivation here. So you have to go through the derivation and write twice or thrice and derive the equation. And note down the scale multiplication ratio, that is R equal to A by B, C by H. So this is very, very important. the examination point of view. This time you can expect this question in the examination. Next, come to the point, the proving ring. So all of you know that all the measuring instruments should be calibrated once in a year or twice in a 2 years in a once in a year or once in a 2 years. You have to calibrate all the measuring instruments. The universal testing machine which we use in basic metal testing lab, after continuous use of 5 years, 10 years, then 15 years or 20 years, there will be a problem in the universal testing machine. So that you have to calibrate. That is nothing but the universal testing machine. There will be hydraulic loading. Hydraulic loading means hydraulic cylinders are present. From that, you can load the specimen up to 50 ton is possible. For that reason, the proving ring is used for the calibration of higher, larger weighing machines. Now, I stop at this stage. I will continue in the next class. And now, all of you, please write down your name and USN in the chat box. All of you, please unmute yourself and tell me the attendance. Yashwant.
Yes, sir.
Ambram. Ambram. Pavan. Pavan T. Pavan H.
Present, sir.
Vedashri.
Present, sir.
Pritam D.
Present, sir. Present, sir.
Renil. Renil. Please
Yes, sir.
tell me your name yourself. I will mark it.
Sir,
Shashank
Anil
HS.
Goda.
Shashank HS.
Present, sir.
Renil Goda. Okay, okay. Shashank
Present,
HS.
sir.
Vinayak N.
Present, sir.
Rahul N.
Yes, sir.
Please pronounce your name. Unmute yourself and tell me the attendance.
Rahul and sir.
Okay.
Rahul MP,
Pritam
sir.
D, sir.
Okay. Okay.
Samram DS.
Okay.
Yashwant S.
Vedashri and Gavda.
Sir Prithvi M.
Okay. Vedashri Gowda. Okay.
Sir Prithvi M.
Please unmute yourself and tell me your name.
Sir
Yashwant S.
Prithvi M.
Okay, okay, Ashwath. Prithvi. Okay. Okay. Now I stop at this stage and I will continue in the next class.
Excuse me, sir.
Tell me.
Sir, third test ಯಾವಾಗಿದೆ sir?
Third test 19th, 20th, 21st.
Okay, sir.
And test is offline. Remember, test is offline. We will conduct the test in the classroom. As we are already conducted the test in the first semester, in the same way, we will conduct the test in the classroom. Third test is offline test. Please attend the classes regularly, not you people. Please inform your friends. Please inform your friends to attend the classes, online classes. Okay? Thank you very much.